Assalamualaikum viewers, my name is Musa Masood and I study in class 6. Welcome to Musa's channel. In today's episode we will talk about the part 2 of the Big Bang theory. This part is sequential to the part 1 of the Big Bang theory which I published recently, in which we discussed about evolution of Big Bang theory and we also discussed about the Quranic references. So in today's episode we will talk about the following topics: the Great Inflation, the Radiation Era, and lastly the Matter Era. So let us move to our first topic, that is the Great Inflation. So viewers, the Big Bang states that almost 13.7 billion years ago all the matter in the universe was compacted at a single point mass that had zero volume due to immense gravitational force, as I told you in my previous video on Big Bang theory part 1. Scientists say that this point mass was infinitely dense, infinitely hot and infinitely small. So small in fact that it was even smaller than the smallest part of an atom. This point mass is known as the primeval atom, as shown over here, and some scientists also call it the cosmic egg. So almost 13.7 billion years ago this point violently exploded, and through this explosion, or we can say bang, all matter, energy, space, time, the universe itself and the four forces of nature were created. So we all know what are the four forces of nature: gravitational force, electromagnetic force, strong nuclear and weak nuclear forces. So let me tell you something amazing about the Big Bang, that it was not actually an explosion, rather it was a very high and extraordinary high intensity inflation. So let me tell you what is the difference between an explosion and an inflation. So let us take the example of a balloon. So when you put gas or air into a balloon, as much as it can hold, we all know it can go and fly in the air, but if we fill more air in the balloon than it can hold, instead of going up, it would just burst at the point and it would just go out of control and nothing would happen afterwards. But if we put less gas into the balloon, instead of going up, it would just fall down onto the ground and collapse and just fall down onto the ground. So what am I trying to tell you, viewers, is that if the Big Bang instead of an inflation were to be a high intensity explosion, so the universe would have bursted and would have just died down just like a bomb does. And if it were to be a low intensity explosion, the universe would expand, but it would just collapse even before it ever reached its present form. So let me tell you another interesting fact about the Big Bang, that the timings played an important role in the Big Bang, because of which the events which occurred at that time started in microseconds. However, the famous physicist Stephen Hawking, who at that time was a member of the materialistic school of thought, has a different point of view regarding the timings of the Big Bang. He attributed 10 to the power of 43 seconds as imaginary time for the Big Bang. But most of the scientists did not believe in this theory and said that imaginary time means nothing. So there was no such imaginary time. So for your interest, I am showing you two slides over here that would give you an idea of how this great inflation might have looked like. This is all about the great inflation. Now let us move to our next topic, that is the radiation era. So viewers, for your better understanding, I have shaped the Big Bang in the form of a glass filled with cocktail. So let us taste this cocktail. The lower half of this glass filled with cocktail belongs to the radiation era and the other to the matter era. We will discuss about the matter era later. So let us take a look at the radiation era. So the radiation era is further divided into 8 epochs. Now let me tell you what is an epoch. An epoch is a long period of time which is long, but it is shorter than an era. So let us move to our first epoch, that is the Planck epoch. So the Planck epoch began immediately after the Big Bang, and the temperature at that time was 10 to the power of 40 Kelvin. Now let me tell you that 1 Kelvin equals to minus 272.15 degrees Celsius. At that time, no matter existed, only energy and the ancestor of the 4 forces of nature, the super force. At the end of this stage, a key event occurred in which gravity splits away from the super force. The next epoch of the radiation era is the GT epoch, or in other words, the Grand Unified Theory epoch. This began almost 10 to the power of 43 seconds after the Big Bang, and the temperature was 10 to the power of 36 Kelvin. During this time, however, the strong nuclear force splits away from the super force, which leads to the beginning of the Inflationary Epoch. During this time, the universe exponentially expanded. Within less than a second, it grew from the size of an atom to as large as a grapefruit. At this time, it was very, very hot, but it became cool enough for electrons, quarks, antiquarks and other particles to also form. Then came the Electroweak Epoch, during which the temperature was 10 to the power of 20 Kelvin and the time was 10 to the power of 32 seconds after the Big Bang. At that time, when the temperature of the universe had fallen enough that the strong force separated from the electroweak interaction, but was high enough for the electromagnetism and weak forces to remain merged into a single electroweak interaction. At the end of this stage, electromagnetic forces and the weak nuclear force split off, which leads an end to the superforce, and all of the 4 forces come into their present form. Now let us move to the Quark Epoch. The Quark Epoch began almost 10 to the power of 16 seconds after the Big Bang, and the temperature at that time was 10 to the power of 12 Kelvin. At that time, in the universe there was a hot, dense quark gluon plasma which filled the entire infant universe. At that time, the quarks and antiquarks tried to collide with each other to form bigger particles such as protons, neutrons, and etc. But at that time, the collisions between these particles were too energetic to form bigger particles or form mesons or baryons. At that time, all of the universe's ingredients were present, all of them were made, but it was still too hot for the subatomic particles to combine together and form bigger particles. So let us move to our next epoch, that is the Hadron Epoch. The temperature was 10 to the power of 10 Kelvin, and the time it happened 10 to the power of 6 seconds after the Big Bang. The temperature of the universe at that time had fallen sufficiently to allow the quarks from the preceding Quark Epoch to bind together into hadrons, and it became cool enough for the quarks to combine together and form protons and neutrons, which are the fundamental building blocks of atomic nuclei. Then came the Lepton Epoch, as shown over here, which began almost 1 second only after the Big Bang. Temperature 10 to the power of 10 Kelvin, and at that time nuclei were formed. Now our last epoch of the radiation era is the Nuclear Epoch. The temperature at that time was 10 to the power of 9 Kelvin, and it happened 100 seconds after the Big Bang. The temperature was right for atomic fusion to create nuclei, and as a result, the first element of the universe was created, helium. This is all about the radiation era. Now let us move to our next topic, that is the matter era. So as you can see over here, this is the other half of that glass, and this represents the matter era. The matter era is also made up of 3 epochs, which we will discuss right now. The first epoch, as shown on the slide over here, is the Atomic Epoch. The temperature was 3000 Kelvin, and the time it occurred during was 50,000 years after the Big Bang. At that time, during the Atomic Epoch, the universe finally cooled and expanded enough for the nuclei to capture free electrons, forming fully fledged neutral atoms. Previously trapped photons were finally free to move through space, and as a result, the universe became transparent for the first time. And as a result of the free electrons forming full-fledged atoms, the second element of the universe was born, hydrogen. Now let us move to our next epoch, that is the Galactic Epoch. This happened almost 200 million years after the Big Bang. At that time, however, the hydrogen atom was created during the Atomic Epoch, and when it combined with helium during the Galactic Epoch, it resulted in the formation of huge atomic clouds which filled the entire universe. Its gravities forced the atoms to connect. Some scientists say that quasars and possibly massive stars might have formed during this epoch, and this is not confirmed, but we do know that galaxies were formed during the Stellar Galactic Epoch. Then the last epoch of the matter era, is shown over here, is the Stellar Epoch. This happened almost 3 billion years after the Big Bang. At this time, the universe came into its present form. Stars formed, and when they died, they released their materials, due to which our sun was born, our earth, life, and everything we see around us came into being, and that's why the Stellar Epoch is known as the last epoch, and it consists of the present day universe. So this is all about the part 2 of the Big Bang Theory. And if you want to watch my previous videos on Musa's channel, the link is given in the description below. So friends, I hope you liked my video. If you did, please subscribe to my channel. Please like this video and hit the notification bell so you will be the first to know when I upload brand new videos. So this is all for today. I am Musa Masood Khan. Take care. Now let us move to our next topic. After this epoch comes the Quark Epoch. The Quark epoch, the grand unified